Look at any crowd on Earth. A busy street in New York City, a train station in Tokyo, a village in Kenya, or a beach in Brazil. And you'll notice something strange. Every person you see belongs to the same species, sharing the same basic skeleton, the same blood, the same brain, and the same ancient family tree. Yet, human skin ranges from extremely dark brown to incredibly pale pink. For thousands of years, people tried to explain that difference. They created myths, then tribes, kingdoms, empires, and eventually, the idea of race, treating skin color as proof that humans belong to different categories, different groups, different kinds of people. But biology tells a completely different story. Skin color was never really about race, superiority, intelligence, or even appearance. Human skin color evolved because every human body faced the same problem, a problem coming from the sky. Strangely enough, the thing that kept humans alive was also trying to kill them, the sun. The same star that grows forests, fills rivers, and makes life possible was also bombarding our ancestors with dangerous radiation every single day. Over hundreds of thousands of years, evolution was forced to solve a difficult puzzle: allow too much sunlight into the body, and important biological systems break down, block too much sunlight, and different biological systems break down. Humans needed a balance, and that balance is written on your skin. To understand how it happened, we need to travel back roughly 300,000 years. Back to Africa. Back to the beginning of our species. Imagine standing in Africa 300,000 years ago. There were no cities, no roads, and no civilization. Only small groups of early humans struggling to survive. And if you could see them, one thing might surprise you. Every single one had dark skin. Not most of them. All of them. The reason was simple. The African sun was incredibly intense. Long before sunscreen existed, humans needed protection from powerful ultraviolet radiation. Unlike most mammals, our ancestors had already lost much of their body hair, allowing them to sweat efficiently, stay cool, travel long distances, and hunt beneath the scorching sun. But that advantage came with a cost. Without thick fur, their skin was directly exposed to dangerous UV radiation. And UV wasn't just damaging skin, it was damaging something far more important: folate, a form of vitamin B9 that helps the body build cells and support healthy pregnancies. Without enough folate, fewer children survive, and evolution ultimately favors whatever helps genes reach the next generation. So, natural selection found a solution: melanin, the pigment responsible for skin color. Melanin acts like a biological shield, absorbing and scattering ultraviolet radiation before it can cause too much damage. The more melanin a person had, the better protected they were. Over thousands of generations, dark skin became one of humanity's greatest survival tools. For a very long time, that solution worked perfectly. Then humans left Africa, and everything changed. For hundreds of thousands of years, humans lived primarily in Africa. Then, something changed. Around 70,000 to 100,000 years ago, small groups of Homo sapiens began leaving the continent. No one announced it. No one planned it. A family moved a little farther, and their children moved farther still. Generation after generation, humans spread into the Middle East, Asia, Europe, and eventually the Americas. As they moved away from the equator, they entered environments their ancestors had never experienced before. The farther north they traveled, the weaker sunlight became. Not because the sun changed, but because the angle changed. Sunlight had to travel through more atmosphere, and more ultraviolet radiation was filtered out before it reached the ground. Days became shorter, winters became longer, and clouds blocked the sky for months at a time. Suddenly, the problem was no longer too much UV radiation, it was too little. And for the first time in human history, dark skin faced a challenge. The human body has a remarkable ability. Your skin can manufacture vitamin D using sunlight. In many ways, it behaves like a biological solar panel. When UVB radiation reaches the skin, it triggers a chain reaction that produces vitamin D, a nutrient absolutely essential for human health. Without enough vitamin D, the body struggles to absorb calcium properly. Bones become weaker, immune systems suffer, and children can develop rickets, a condition that causes bent legs, slowed growth, and skeletal deformities. For women, the consequences could be even more severe. Vitamin D deficiency could soften and deform the pelvis, making childbirth far more dangerous, and sometimes even deadly. Now, imagine a dark-skinned human living in Northern Europe 40,000 years ago. The same melanin that had provided excellent protection under the intense African sun was now blocking precious UVB radiation in a region where sunlight was already scarce. As a result, the body could no longer produce enough vitamin D. Generation after generation, survival became more difficult. Evolution faced a dilemma. The solution that had worked perfectly in Africa no longer worked in the north. And so, nature began searching for a new answer. For a long time, scientists assumed Europeans became pale soon after arriving in Europe. DNA evidence revealed a different story. In 2018, researchers analyzed the remains of a man known as Cheddar Man, who lived in Britain around 10,000 years ago. The results surprised many people. Cheddar Man likely had dark skin, dark hair, and blue eyes. That combination seems unusual today. But thousands of years ago, it may have been common across parts of Europe, which means the pale skin many people associate with Europeans today appeared much later than most people realize. In fact, extremely fair skin only became widespread around 6,000 to 8,000 years ago. So what happened? The answer was agriculture. Around 8,000 years ago, humans began farming. Hunter-gatherers ate fish, shellfish, and wild animals, rich in vitamin D. Farmers relied much more on grains. As dietary vitamin D decreased, people depended more heavily on sunlight. That increased the advantage of lighter skin. At the same time, larger farming communities helped useful genetic traits spread faster. Evolution accelerated. Within a few thousand years, skin pigmentation across Europe changed dramatically. But Europe wasn't unique. East Asians also evolved lighter skin. Here's the surprising part. They didn't use the same genetic changes. Different populations, different genes, same result. Scientists call this convergent evolution. Evolution found two different ways to solve the same problem: getting enough vitamin D in low sunlight environments. Skin wasn't the only thing changing. Blue eyes appear to trace back to a single ancient mutation that emerged roughly 6,000 to 10,000 years ago. Before that, every human likely had brown eyes. One mutation, one ancestor, millions of descendants. And today, that tiny genetic change can still be seen all over the world. For most of human history, skin color was shaped by geography, sunlight, and the constant challenge of survival. Today, however, technology has changed the rules. We have sunscreen, vitamin D supplements, modern medicine, and the ability to travel across the globe in a matter of hours. As a result, people can now live almost anywhere on Earth, regardless of the environment their ancestors evolved in. Yet, our skin still carries the memory of those ancient worlds. And perhaps, that's the most important lesson of all. Skin color was never a ranking system. Evolution never created it to divide humanity, and it never cared about race. It cared about survival. Dark skin was not primitive, and light skin was not advanced. Both were solutions to different environmental challenges. Every human alive today descends from the same ancient population that emerged in Africa hundreds of thousands of years ago. We are the same species, sharing the same distant ancestors, shaped by different environments and different adaptations. So the next time you look at your skin, remember that you're not just looking at a color. You're looking at a survival story, a map of ancient migrations, and a record of sunlight written onto the human body. Every shade is evidence of adaptation, and every color tells part of the same human story.